So we're given A as 15.3 and then B as 5.112, C as 3.9567. Dinner class in the class. D as 11.9457. Okay, and then they say determine the error in the calculation K equals to A squared B C over D. Okay, and then they also say and determine the interval of accuracy NKB, the best accurate value of K, where change in A, we are given that change in A it's 0.05, change in B 0.005, and change in C is equals to change in D, which is equals to 0.0005. And do you guys open the textbook?
Yes.
Okay, so I won't write the change in A, B, and C. We're just gonna check them on the textbook. So what we're gonna do first, remember they say we have to determine the error. Okay, so we have our variables. We have K, A, B, C, D. So to determine the error, we're gonna derivate this equation. We're going to derivate this equation. So to derivate it, so it's gonna be change in K, okay, equals to partial derivative of K over partial derivative of A. Remember we have A squared BC over D. So we're going to derivate K with respect to A, B, C, D. Okay, so this is how we're gonna derivate. So it's gonna be partial derivative of K over partial derivative of A multiplied by change in A, the absolute error of A, plus now we're gonna come to B. So it's gonna be partial derivative of K. Remember we're derivating K with respect to A, B, C, D. So it's gonna be partial derivative of K over partial derivative of B multiplied by change in B. Okay, plus now we're gonna come to C. So it's gonna be partial derivative of K over partial derivative of what? Of C multiplied by what? By changing C. And then we have D plus partial derivative of K over partial derivative of D. Okay, multiplied by what? By changing D. Okay, so we have these variables. Okay, and then remember all these derivative, we're gonna introduce the absolute bar in them. So it's gonna be absolute bar of change in K, and then absolute bar of this multiplied by absolute bar. We'll introduce the absolute bar here. Okay, like this. Okay, so after here we wrote our equation. So here it shows that it's the derivative of K with respect to A and then changing A. Okay, and then we were given the value of A, B, C, D, and changing A, B, C, D. Okay, there's no E, A, B, C, D. Okay, so what we're gonna do here, we're gonna come to our equation K is equals to A squared B, C, D, and then here at first they want us to derivate K with respect to what? To A, which means we're going to focus at A, okay? A squared BC over D. So how are we going to derivate A in this equation? Do you have any idea how we're going to derivate A squared BC over D? But we're going to derivate K with respect to A. What's the derivative of K over derivative of A? Do you have any idea how we're going to derivate it? Okay, how do we derivate it?
When we derivate this one, we have to sorry.
Yeah, you can continue.
Yeah, so since we are going to be derivating focusing on A
yes.
next, we will derivate A.
Yes. So derivative of A squared is going to be 2A. Yes, and then we copy everything. So it's going to be BC over D. and then times change in A. Okay, and then when it comes to B, we're gonna focus only on B, right? Derivative of B, it's b to the power of 1, so it's gonna be 1. So we're gonna left with what? With A squared C over D. Okay, and then multiply by changing B. Okay, and then when it comes to C, we're gonna focus on C. So C, derivative of C, it's 1. So we're gonna be left with, let me write on the other page, sorry. So changing K, we have 2A BC over D. Here we have A squared C over D. And then C is gonna be A squared B over D. Okay, do you agree? Remember our equation is K is equals to A squared BC over D. Wongani, are you following? Wongani? I think it's not here. Okay, but let's continue. And then D, how are we going to derivate D?
That's where I get lost.
Is it? Okay, it's fine. So we have two methods, but I'll show you the first one. This one is the easiest one. Remember, we have K is equals to A squared BC over D. We can take this D to the numerator. So this is the same as A squared BC multiplied by D to the power of -1, right? Do you agree?
Oh yeah, yeah.
Do you agree? So now we want to derivate D. So it's going to be -1 multiplied by A squared BC times D to the power of -1 minus 1. Remember, when we derivate, we add, we minus.
Add 1.
We minus.
What do we add? Oh yeah, we minus.
So it's going to be a negative, this one we took it down. It's going to be negative A squared BC multiplied by D to the power of -1 minus 1, because we're derivating. Okay, therefore it's going to be a negative A squared BC times D to the power of what? A -2, right? So since we have a negative, it's the same as 1 over D squared. D to the power of -2 is the same as 1 over D squared. Do you agree?
Yes, please.
Okay, so therefore, let me erase this. So therefore, the partial derivative of K over partial derivative of D is going to be a negative A squared BC over D squared. We just changed the D to the power of -2 to what? To 1 over D squared. So it's going to be 1 multiplied by negative A squared BC. So we have a negative A squared BC over D squared. So here we're going to have a negative A squared BC over D squared times changing D. Right? Are you following? Do you have any question here? Okay. You guys don't have any question. And then now we have this equation. What we're going to do, we're just going to substitute. Remember, we are given that A equals to 15 and 15.3, B is equals to 5.112, C 3.956, D 11.9457, and then here you're just going to substitute the values of A, B, C, and D. And then we also have the value of change in A, which is 0. Where is it? Change in A is 0.05. So you substitute your values and then you're gonna get your answer, change in K. Okay, and remember we said when we're calculating the absolute error, the final answer we write it in equalities. So it's gonna be less or equals to. Okay, so here you're just gonna substitute. Let's say you substituted and then you get your answer as we're just gonna copy the answer, because here we just substitute the value of A, which is 15.3, and then the value of B, which is 5.112, and then you substitute them, and then you're gonna get answer as 2.6361. Okay, so your answer is gonna be 2.6361. 0.6361. So this is your answer. And then they also ask us to determine intervals. Remember, to determine intervals, we're going to calculate the value of k, right? To calculate the interval, we start by calculating the value of k. So k, it was a squared bc over d. So we're going to substitute the value. So it's going to be 15.3 squared multiplied by 5.112 multiplied by 3.9567. Okay, and then divide by the value of d, which was 11.9457. okay, and then you get the value of k. Okay, the value of k is gonna be what? 396.3649. Remember, the reason why we're calculating the value of k, we want the intervals, because they ask us to determine what? The intervals. So to get the intervals, it's gonna be k, this k minus 2.6361 on the left, and then 396.3649 plus 2.6361 on the right. So these are the intervals. Let's write the intervals. So intervals is going to be k between this and this. So it's going to be 396.3. Let me just erase a little bit. 0.3649 minus 2.6361. This one is for changing k, right? And then this one is k. So here we are writing what? Intervals. We are writing intervals, okay? And then here it's going to be 396.3649 plus 2.6361. And then this is how we do what? Intervals. We call this intervals. We call these intervals, okay? These are the intervals. When they ask us to determine intervals, you start by calculating the absolute error, and then you calculate the value of k, the original formula, and then you substitute your values. After that, you do the intervals. Do you have any question here?
No.
Okay, you don't have any question. So this is how we do it. So every time when we have the variables, you check your variables and then you write your equation depending on the variables you have. Okay, it's gonna depend on the variables that you have. The equation is gonna depend on the variables you have. So let's say I don't know, I think you guys, you should just do activity. After this, you should do the activity. I have the solutions. If you want them, I'm gonna send it to you. Okay, so let's say we have this v. Let's say we have v equals to pi r square h, and then they ask you to determine the error of v. How are you going to write the equation if you have this equation? Remember, to write the equation, we check our variables. How are we going to write the equation with this formula? V is equals to pi r squared. Do you have any idea how are we going to write the equation of absolute error? Hello? Guys, are you still here?
Yes, we still follow.
If you don't know, just tell me. Oh, we don't have any idea, Cheza. Just show us. Okay, it's fine. Remember I said when we write equation, we check the variables. We have variable, we have v, we have r, we have h, because pi is just a number. It's 3.14, I think. So if we have these three variables, it's going to be change in v equals to the partial derivative of v over partial derivative of r multiplied by what? By changing r, okay? Plus partial derivative of v over partial derivative of h. Time is changing h. This is how we write the absolute error equation. Okay, this is how we write it. We check the variables. Are you following? Yes, and then from here you're just gonna derivate r v with respect to r, and then derivate v with respect to h. Are you following? Yes. Okay, sharp. I want to
Can I please ask?
Yes.
Why are we not including pi?
Pi is the value. It's 3 points. It's not a variable. It's the number, right? You know that pi equals to 3.1.
3.1, yeah.
Yes, 3.14, yes. So it's not a variable. So when we write our equation, we check variables.
Oh, okay, thank you.
Yes. So I want you to give me the equation of this. Let's say we have t equals to ab over c squared d cube. So I want you to give me the equation of this formula. Of this t is equals to ab over c squared d cube. How are we going to write the absolute equation, absolute error equation? If we have t is equals to ab over c squared d cube, how are we going to write it?
I think now on this one, the first thing that we do when we want to determine the error,
yes,
we'll say, okay, let's say now since we have ab divided by c squared d cube,
yes,
we'll have to focus on a first, and then with a we know that we do not have any exponent. So
no, sorry. Before derivative, I want you to come with the equation like this. While you have t, let me write it this side. We have t equals to ab over c squared d cube. I want you to come with that equation. Changing t is going to be equals to what? You see this side, I said we have 3 variables.
I think it's going to be change of
partial.
t to
partial. Yes.
I need to. We're starting with change of t.
Okay. Yes. Changing t equals to yes.
Partial of t divided by partial of a.
Yes.
Change of a.
Yes.
Plus partial of t divided by partial of, what's that one? It's
b. Yeah, it's b.
Yeah,
sorry.
b.
It's b.
Partial
ab.
of b. And then change of b. Plus partial of c squared.
No, it's just t over c. Time is changing c. Okay, guys, you don't check the squared, you just check the variables. So we have t equals to ab over c squared d cube. So our variables here, it's t, a, b, c, d. So we have 5 variables.
No, okay.
Yes, so
the only time we consider
square
root and what is when now we are derivating.
Yes, correct.
Oh, okay.
So it's going to be plus partial derivative of t over partial derivative of d. Time is changing d, okay? And then when you consider c, it's when you are derivating what? C here, okay? Yes. So when you're derivating, you're gonna consider square c squared. You're gonna consider square, and then when you derivate d, you're also gonna consider cube. Okay. So here you're gonna say, partial derivative of t with respect to partial derivative of t with respect to a, you're going to check here. When we derivate, how do we derivate a on this equation? So we're going to focus only on a, so it's going to be b over c squared d cube. And then when it comes to b, it's going to be a over c squared d cube. Okay, and when it comes to c, remember we can write our equation like this because we're dividing. We can write it as ab c to the power of minus 2 d to the power of minus 3. Okay, and then now we're going to focus at c. So c is going to be a negative 2abc to the power of minus 3, and then d to the power of minus 3. Because remember, when we derivate, we minus here. So minus 2 minus 1 is going to be minus 3. And then which means the partial derivative of t with respect to c is going to be minus 2a b over c cube d cube. Okay, this is the partial derivative of c. And then for d, did you follow that, guys?
No, can you please repeat that one?
Okay, let me repeat. We agree. Okay, let me just derivate everything from the start. For a is gonna be b over c squared, okay, d cube. Do you agree with that when you are derivative a? And then for b is gonna be a over c squared d cube. Do you agree with that? We derivated b. Derivative of b, it's 1. 1 times a, it's a. Okay, so it's going to be a over c squared d cube. Okay, and now when it comes to c, we have this. We can rewrite our equation like this: ab c to the power of negative 2 d to the power of minus 3. Do you agree with that? Or okay, t is the same, is also equals to ab c to the power of minus 2 d to the power of minus 3. Do you agree with that, right?
Yes.
Okay, sharp. And then now we want to derivate c. So remember product rule. In product rule, I said we copy, we derivate, we copy, we derivate. And now we are focusing at what? At c. So derivative of negative of c to the power of minus 2, it's what? It's negative 2 c to the power of minus 3. Do you know that, right? Do you know how did we derivate that? Derivative of c to the power of minus 2 is negative 2 c to the power of minus 3. Do you agree?
Yes.
Okay, and then now we are down derivative c, and then we're going to copy the remaining. So we're going to copy a, b, and d to the power of minus 3. And then this, we can write it as negative 2ab over c to the power of 3 d to the power of 3, because we say that c to the power of negative 3 is the same as 1 over c to the power of 3, and then same as d is the same as 1 over d to the power of 3. So that 1 we multiply with the negative 2ab, and then we write it in a fraction form. So the derivative of t over derivative of c, it's negative 2ab over c cube times d cube. Did you get that?
Yes.
Rochi? Rochi, did you get that?
No, I don't get it.
Okay, let me repeat again. Let me open another page and write it in a clear space.
So I don't get the part where we are writing it as a fraction. Like,
Okay.
don't we take this d cube on the numerator?
Wait, agree we have this. Okay, and then now you agree that we can write it as this, right? You agree? Yes.
Yes.
And now we want to derivate c. How do we derivate c to the power of minus 2? What is the derivative of c to the power of minus 2?
Negative 2c.
And then
To
we're
the power
going
of negative.
to the power of negative 3. Okay, and then we're just gonna copy the other variables that are left. Okay, this is D. Okay, so now do you agree that c to the power of minus 3 is the same as c to the power of 3? Do you agree? And also, d to the power of minus 3 is the same as 1 over d to the power of 3. Okay, you agree with that? Yes. And now we want to write our equation in a fraction form. So to write it, it's going to be a negative 2 1 over c cube times ab times 1 over d cube, right? And now we're gonna take out our LCD. Our LCD is gonna be c cube times d cube. So it's c cube and d cube. So negative 2 times 1, it's negative 2. And then we have AB times 1, it's gonna be AB. So it's gonna be negative 2 AB. So this is a fraction form of what? Partial derivative of t over partial derivative of c. Do you get it? Yes, that's how we write it in a fraction form.
Okay.
Sure, you did get it.
Yeah, I do get it now.
Okay, now we are done with the partial derivative of t over partial derivative of c. Let's come to partial derivative of t over partial derivative of d times d. So I want you guys to determine the partial derivative of t divided by partial derivative of d. Okay, so can you please do the partial derivative of t over partial derivative of d? It's going to be equals to what? Remember, our t equals to a b over c squared d cube. So I want you guys to determine the partial derivative of t over partial derivative of d. I'm gonna give you 2 minutes. Or you want to tell me so that I can write it out?
I think I did try it, but let's wait for Rochi to do it as well.
Okay, Rochi, I'm just giving you 2 minutes. Okay, what's the partial derivative of t over partial derivative of d? Okay, Wangani, you can give what you got.
My final answer
Yeah.
is going to be minus 3 AB
Yes.
divided by c squared d to the power of 4.
Yes. Great. That's true. That's correct. So Rochi, did you get it? Did you get the same?
Let me tell you what I got, Nick.
Okay.
So I wrote it as AB divided by c squared multiplied by 3d to the power of -4, ne? So I think I'm still struggling with
making it in
yeah.
changing to fraction. Okay, let me show you. So we have AB c squared -6c squared negative cube, like this. Okay, so we want to derivate d, so it's gonna be a derivative of d to the power of -3 is gonna be -3 d to the power of -3 minus 1, which is gonna be -4, and then we're gonna copy a b c -2. Okay, then here is gonna be, let me just write -4 here. Here is gonna be -4. Okay, so now from here we're gonna say -3 multiplied by 1 over. Can you hear me? Oh, okay, let me restart. So here we're gonna derivate d to the power of -3, so it's gonna be a -3d to the power of -4. Okay, you still here, Rochi? Yes, and then we copy a b c to the power of -2. Yeah, and then,
I can hear you now.
Okay, and then here we derivated d to the power of -3, which is -3d to the power of -4, a b c to the power of -2. And now to write it in a fraction form, it's going to be -3 1 over d to the power of 4, okay, times ab multiplied by 1 over c squared. Okay, and then our denominator is going to be d to the power of 4 c squared. So the partial derivative here is going to be d to the power of 4 c squared all over, this one is going to be our denominator, and then the numerator is going to be -3 times 1, which is -3, and then 1 times ab is going to be ab. Okay, like this, the same as what Bungani got, ne? It's the same. So this is how we change this function to fraction, and we change this d to the power of -4, we change it to fraction as 1 over d to the power of 4, and then c to the power of -2, we change it to fraction, it's going to be 1 over c squared, and then we simplify. Did you get it? Okay, so this is how we derivate. Okay, so moving forward, I want us to start with unit 2 today. Okay, so we're gonna do 1.4, the general iterative method. Okay, so this actually, before moving forward, this is how we write our equation. Okay, we start by checking how many variables do we have, and then we write our equation in terms of the variables that we have. After that, we derivate. We're gonna derivate, and then we substitute the values. We're gonna be given the value of a, we're also gonna be given the value of b, c, and d. You'll be given that, and then you substitute your values. Okay, sharp. And then let's do 1.4, the general. Do you have any question? Okay, the general iterative method. So in this method, we're going to use a linear. Actually, this iterative method uses it. We use it on a linear equation. So we're gonna use it on a linear equation. Okay, and then we also have what do you call a Newton-Raphson 1.5, a Newton Raphson method. Okay, so this one we use it on non-linear equation. This one is for non-linear equation. Okay, non-linear equation. So guys, do you know the linear equation, difference between linear equation and non-linear equation? Guys.
Linear equation. I know that the linear equation is y equals to mx plus.
Yes, that's true. That's true. Yes, it's a straight line. It's a straight line. And it doesn't have the square root. It doesn't have the power. It only has the power to the power of 1. To the power of 2, 3, blah, blah, blah. It's not a linear. Okay. So this general alternative method, it uses linear equation, and Newton's Raphson method, it uses non-linear equation. So non-linear equation is the one that have square, the trigonometric, the square root. Those are non-linear equation. Okay, so we're gonna focus on Newton-Raphson method. So here we have a formula. We're going to use a formula of Newton-Raphson method. We have a formula. This is the formula for Newton's Raphson method. So it's x n plus 1 equals to xn minus f into xn over f prime xn. So here it shows that we're going to derivate f prime. It shows that we're going to derivate. Okay, this is derivate. We're going to derivate here. Okay, so the n start from 0, 1, 0, 1, 2, 3, and then 4, 5, 6, 7, 8, 9, 10. So n will start at 0. Okay, so from now here we're gonna do an example on how to use this Newton's Raphson. Okay, so in this Newton Raphson, we're gonna use this formula. What we're going to do, we're gonna substitute 0 at n, so it's gonna be x 0 plus 1, x 0, and then wherever this n, we're gonna put 0. Okay, so it's gonna depend on the information that we are given. So we're gonna do activity 1.4 and show you how to calculate the Newton's Raphson method. Okay, so activity 1.4, they say use Newton's Raphson method to approximate the roots of the following equations, correct to 3 decimal places, subject to the initial condition given. Number A, we are given that x minus cos x equals to 0, and then we're given that x0 equals to 0.7. Okay, so we are given this formula, we're given this function, and then they want us to use the Newton-Raphson method to approximate the roots of the following equation, and then we have to correct our answer to what? To 3 decimal place. To 3 decimal place, subject to the initial condition. Our initial condition is 0.7. Guys, are you still here? Hello? Okay. Wongani, are you still here?
Yes.
Oh, okay. So we're gonna write our equation. Our formula is x n plus 1 is equals to xn minus f of xn over f prime of xn. This is our formula. This is the formula that we're going to use to determine the approximate roots. Okay, so the first thing that we have to do, you see here we have the function. Our function is x minus cos x, and then the f prime we have to derivate. So the f of x is gonna be x minus cos x. Okay, and then the f prime is gonna be, what is the derivative of x? It's 1. And then what is the derivative of cos? Negative cos. Okay, let me just say cos. What is the derivative of cos? It's a
Isn't it
negative,
minus sign?
yes, a negative sign x. So now we have the f, we also have the f prime. So wherever there's fx, we're gonna use this equation, and wherever there's f prime x, we're gonna use this equation. Are you following? Agreed, we have this equation, formula for Newton's-Raphson. It's xn plus 1 is equals to xn minus f into xn over f prime of xn. So the first step is to write our function. Our fx, we're just gonna copy the function that we're given. It's x minus cos x, and then we derivate that function. Okay, so which means here we're gonna have 1 plus sine x. Okay, we just add negative and negative. We multiply negative and negative, so we get a positive sine x. Okay, so now we're gonna copy again our formula, but when we copy now, we're gonna put 0 here at n. So to determine which number we're going to put here at n, we check the initial condition. It started what? X0. So which means our n is what? It's 0. Okay, so we're gonna have x0 plus 1 equals to x0 minus f into x0 over f prime x0. Okay, remember our f, it's x minus cos x, and then our f prime, it's 1 plus sine x. So wherever there's x, here it's 0. Okay, so wherever there's x, we're gonna put the subscript of 0. So it's gonna be x0 cos x0 1 plus sine x0. Okay, so now we're going to have x 0 plus 1 is 1, so we're gonna have x1 equals to x0 minus, we're gonna write our equation, so it's our function x0 minus cos x0 over 1 plus sine x0. And remember, from the quotient, we are given that x0 is equals to what? It's equals to 0.7. So wherever there's 0.7, we're gonna put wherever there's x0, we're gonna put 0.7. Okay, so the reason why we're calculating this Raphson method is to find the next value. So we're gonna calculate x1, x2. When we get the value of x1 as 0, we're gonna continue and calculate the value of x2. If we get the value of x2 as 0, we stop. Okay, let me show you what I'm saying. So let's just substitute the 0.7 minus 0.7 minus cos 0.7, okay, over 1 plus sine 0.7. Okay, if our x1 is equals to x2, that's where we stop our calculation. And if our x1 is not equals to x2, we continue and then we calculate x3 up until we get the same values. That's the Newton-Raphson method works. That's how Newton's Raphson method works. So if our x1 is equals to x2, we stop. If it's not equals, we continue and then we determine x3. If our x3 is not equals to x2, we continue. If they're equal, we stop. Okay, do you get that?
Yeah.
Okay, yes. So we're going to calculate x1, and then after x1 we're going to calculate x2 until we get the same values. Okay, and then when we get the same values, that's where we stop. Because they say we have to use the Newton's Raphson method to approximate the roots. So if the x1 and x2 are equal, we stop. If they're not equal, we continue and calculate x3. Okay, sure. So now we want to calculate our x1. So x1 equals to 0.7 minus 0.7 minus cos into 0.7 over 1 plus sine 0.7, and then we're gonna get our answer. Can you please calculate this?
getting 0.7394.
73. Remember, they say we have to round off our answer to 3 decimal place, ne? So it's gonna be 0.739.
Right.
Okay, so we get our x1. Now we're going to calculate x2. So we want x2. Remember, our equation is n plus 1 is equals to xn.
I'm not getting the same answer.
Remember, I told you your mode of a calculator is supposed to be in radian when we have a trigonometric. How much did you get?
I got 0.37.
37. Did you set your calculator to radian?
Yes, I did. Let me calculate again.
Okay. It's 0.7 minus, and then you make a fraction. So it's going to be 0.7 minus cos 0.7 over 1 plus sine 0.7.
Yeah, now I got the same answer.
Okay, fine. It's 0.739. Now let's continue and calculate x2. Remember, I said here we have to get the same answer. That's where we're going to stop. So we're going to write our equation. Now we're looking for x2. Okay, so which means x2, to get x2 is going to be x1 plus x1 plus 1. Okay, so here our n is going to be 1. Remember, we started at 0. Okay, we started at 0, x0. So now we calculated x1, and then which means our x1 is equals to that value. X1 equals to 0.739, right? So here it's gonna be x1 plus 1 equals to x1 minus f x1 over f prime x1. Remember, our f, it's x minus cos x, and then our f prime is 1 plus sine x, and then wherever there's x, we're gonna put the subscript 1. Okay, that's it. So now our x2 is gonna be x1, the value of x1, we're gonna take the one that we calculated. So make sure that you did the right thing, because you're gonna use your answer to the following equation. Okay, so make sure you get the right answer. If not, you're gonna get 0. Okay, so it's gonna be 0.739 minus our equation. Our equation x1 is 0.739 minus cos 0.739. Can you please calculate this? Over 1 plus sine 0.739, and then we're going to get our answer, our x2.
I'm getting 0.739.
So you see, our x1 and x2 are equal. So that's where we stop. If they were not equal, we were gonna continue and do what? And do x3. And if our x3 is not equals to x2, we were gonna do x4. So. Okay, so which means our x1 and x2 are equal. That's where we're gonna stop to calculate. And that's it. That's how Newton's Raphson method works. So I want you guys to do number. Do we still have time? Yeah, we still. After this activity, we're gonna start with unit 2. Okay, guys, I want you to do number B. I'm giving you 5 minutes. Oh, is it 5? Yeah, 5 minutes. I'm giving you 5 minutes. 2 minutes. By 8 o'clock, you'll give me the answer. Okay. Are you fine with that 2 minutes, or you want extra? Yeah.
We'll just try.
Yeah. Do number B and then give me your answers. B, it's e to the power of x minus 2x minus 5 equals to 0. And then they say x 0 is equals to minus 2. Or actually, let's do it together. You guys are just gonna give me, or what should I write? Okay, let's do it together. Yes, I said the first step is to write our function and then we derivate it. So give me the answers. So I'm gonna start with Rochi. Okay. Yes.
Still on the first.
This is our function. I want you
Yeah.
to derivate. What is the derivative of e? To the power of x. You can check the formula sheet. Bongani, can you please help her? What is the derivative of e to the power of x?
I'm not sure, but I think it's going to be x ln e.
No. Derivative of e, it's derivative of e. It doesn't change. Okay?
Okay.
Yeah. The derivative of e, it doesn't change. It's e to the power of x, e to the power of x. Yes.
Why?
It's I don't know, it's gonna take me time to prove it, but I'm gonna write it down and send it to you. I'm gonna solve it and send it to you and see it's the same thing, because now it's already 8 o'clock.
Fine.
Yeah. So just know that the derivative of e to the power of x, it's e to the power of x. Ane?
Okay.
And then the derivative of negative 2x,
-2
negative 2. Derivative of negative 5,
at 0.
yes, it's 0. So now I want you to calculate x1. Wangani, how to calculate x1? We have that
X1.
formula. Yeah, we're gonna use this formula. Xn plus 1 is equals to xn minus f into x over f prime x. We're gonna use this formula. So
Okay.
did you write it down?
The formula.
Yes.
Yeah, I did.
Okay.
So we're starting with x1, right?
Yes. Remember here it's 0 plus 1, so it's gonna be x1.
Yeah, it's going to be x 0 plus 1. It's equals. Should I mention the formula or
Give me the answer, the workings.
the answer?
Yes.
The answer.
Yes.
Okay. Going to be x 0. No, x. Yeah. X1. No, x 0. Okay, x1. X0 minus e to the power of x minus 2x minus 5 divided by e to the power of x minus 2.
Rochi, are you following?
Yeah, I'm following.
Okay. And then we do have the value of x0, which is minus 2. Okay, so wherever there's x, we're gonna put the subscript 0, 0, 0. Okay, so now it's gonna be minus e to the power of minus 2 e to the power of minus 2 into minus 2, right? Minus 5 over e to the power of minus 2, and then we're going to get the answer. So my answer is negative 2.464. Okay, and now from here we're going to calculate x2. So x2, wherever there's x0, we're going to put x1, right? Okay, so now we want x2. x2 is going to be 1 plus 1 equals to x1 minus f of x, which is e to the power of x minus 2x minus 5. And then over f prime of x, which is e to the power of minus x, e to the power of x minus 2. Okay, so it's gonna be x2 equals to our x1, we got it as negative 2.464 minus e to the power of this minus 2 into negative 2.464 minus 5. Okay, over e to the power of minus 2.464 minus 2. And then our x2, I got x2 as negative 2.457. And remember our x1, it's what? It's negative 2.464. And then x2 and x1, they are not equal, which means we have to continue and determine what? And determine x3. So x3 is gonna be x2 minus e to the power of x2, right? Minus 2x2 minus 5 over e to the power of minus x2 minus 2. And then wherever there's x2, you're gonna put negative 2.457. So x3, you're gonna get answer as you're gonna get your x3 as negative 2.457. And then you find what I mean, our x2 equals to what? To x3, and then that's where you stop. Okay?
Yes.
Okay. Rochi, are you still here? Am I too fast?
Yeah, you are too fast this time, eh?
But you are following. Sorry. Are you following?
Yeah.
Okay. So Newton's Raphson, you use the equation, and then you write your function, you derivate your function, and then you substitute. Okay, you're gonna substitute x0, and then after getting x1, you're gonna calculate x2 with the value of x1. Okay, and then after getting x2, you check if your answers are the same. If they are the same, you stop. If they are not the same, you continue to calculate x3. Okay, and if your x2 is equal to x3, you stop. And if they are not equal, you continue and do x4. Okay. Yeah, that's what you do. So this is the formula. This is the formula. Okay, this is the formula. Xn plus 1 equals to xn minus f of x over f prime of x. You'll be given the value of x0. So you check, okay, if it's x0, which means your n is gonna be 0. If it's x1, your n is gonna be 1. Okay, so here we were given that x0 is equals to 0.7. Okay, it's here. Yeah, we were given that x0 is equals to 0.7, which means wherever this x, you're just gonna put the subscript 0. Wherever this x, you put the subscript 0. Okay, and then you get your x1. And then to get x2, wherever this x, you're gonna put subscript 1. Okay. Okay. Okay, let's continue and start with unit 2. Or before continue, do you have any question under Raphson method? Guys, are still here?
No.
Okay.
From my side, I feel like it's straightforward.
Yeah, this one, it is straightforward because you just substitute. Okay, let's do unit 2. And then we're gonna continue. Let's continue with unit 2. Let's start with unit 2. So unit 2, it's finite difference and interpolation. Rochi, have you started with unit 2 or you were still in unit 1?
I was still in unit 1.
Okay, so guys, I think I should just send you the workings of the activities, and then you're just gonna mark yourself, and when you don't understand, you're gonna ask me. What do you think? Is it fine with you, or you want to start by doing it and then you're gonna compare it later?
No,
I think that's fine.
I wanted to say so as well.
Okay, I'm gonna send you the solutions, and then when you practice, you compare, and then if you don't understand, you're gonna ask me. Okay, so unit 2, it's finite difference and interpolation. So here we have 2 types of interpolation. Okay, so the first one, it's linear interpolation, and then the second one, it's quadratic. Okay, so we have the linear and quadratic interpolation. Okay, so let's start with the linear interpolation. So let's say we have A. At A we have x0 and y0. Okay, and then at B, these are the points. At B we have x1 and y1. Okay, these are our points. So here under linear interpolation, we have equation. Okay, we have the equation. We have a polymer. We have P into x. The P, we call it polynomial. Okay, P into x is equals to L0. This is the equation that is from the textbook, multiplied by fx0 plus L1 f into x1. So to get more information, you can check your textbook. Okay, so the fx0 is gonna be our y0, and then this one is gonna be our y1. Okay, sharp. So let me just write the equation of linear interpolation. So the L0 is the same as x minus x1 over x0 over x1. So let me just write in full. Okay, so it's gonna be, this is the linear interpolation. So we have the P into x equals to x minus x1 over x0 minus x1. Okay, multiply by f into x0 plus x minus x0 over x1 minus x0. This is the formula, it's there on the textbook. Multiply by f x1. Okay, like this. This is a linear interpolation. It's a linear interpolation. And then do you want to say something? Okay, it's fine. So we also have a quadratic. Let me write it in different color. The quadratic one, it's P into x equals to x minus x1 over x0 minus x1 times x minus x1 over x0 minus x2 multiply by what? By f of x0. So the quadratic one, this is the quadratic. The quadratic one, you can see its multiplication is gonna have a square. It's gonna have to the power of 2 to show that is what? It's a quadratic, because you see x minus 1 times this, x minus 1, so it's a quadratic. This is a quadratic interpolation. Plus x minus x0 over x minus x0 times x minus x2 over x1 minus x2. These equations are there in the textbook. You'll find them there. Multiply by f of x1. Okay, so this is the quadratic equation. Okay, so what we're going to do here, we're going to do example in unit 2. We're going to do this example 2.1. Okay, it says determine the linear interpolation polynomial that best fit the points. We have q 1 over 2 and 0 and r 3 and 5, and then use the polynomial to estimate f into minus 1. Okay, we have the formula for linear. This is the linear equation, and then we are also given what the points q and r. We also have the polynomial to estimate f into negative 1. Okay, so let's do that example. So we are given q as 1 over 2 and 0. Okay, and r as 3.3 and 5. Okay, like this. And they also want us to estimate f into negative 1. So we have our equation of linear interpolation. It's p into x is equals to x minus 1, x0 minus 1, f of times f of x plus x minus 0 over x1 minus x0 times f x1. Okay, so from these points, we're gonna say our half, this is half, is gonna be our x0, and then this one is gonna be our y0, and then here at r, it's r3 and 5. Okay, so our 3 is gonna be our x1, and then our 5 is gonna be our y1. So from here, we're just gonna write our function. So remember, it's px equals to x minus x1 over x0 minus x1 multiplied by what? By f of x0. Remember, f0 is y0, it's the same as y0, plus x minus x0 over x1 minus x0 times f of x1. x1 is the same as y1. So from here, we're just gonna substitute. Okay, we don't have x, so we're just gonna copy it. Minus x1, our x1 is what? It's 3. Okay, over x0, our x0 is 1 over 2, minus our x1 is 3. Okay guys, are you following?
Yes.
Okay, and then y0, our y0 is 0 times 0. Okay, plus here x, we don't have x, minus x0, it's half, over x1 it's 3 minus x0, which is half, times f of x1 is y1, our y1 is what? It's 5 times 5. And then just know that any number multiplied by 0 is what? It's 0, which means we're gonna be left with what? With this part only, because this one is gonna be 0. Any number multiplied by 0, it's 0. So which means we're gonna solve x minus 1 over 2 over 3 minus 1 over 2 times 5, right? So our p of x is gonna be equals to x minus 1 over 2 over 3 minus 1 over 2 times 5. Okay, and then we have to solve this. So 3 minus 1 over 2, it's 5 over 2. Okay, so we're gonna have x minus 1 over 2 over 5 over 2 multiplied by 5. like this. And then we're just gonna simplify this. To simplify, 5x minus 1 over 2, and then 5 over 2. Okay, and now we simplify the 5 over 2. We can write it like this.
Proceed to the next.
Just send on a recording there.
So remember here we have 5 over 2. So we're just gonna rewrite it and then write it in proper fraction. So it's gonna be 5 into x minus 1 over 2.
Can you please mute your mic?
Okay, guys, are you still following from here? We started here. Okay.
I got lost.
Where?
I got lost on the following step.
Here.
You said x1 over 2 divided by... Okay, now I see. I see now.
Okay, here we substituted and then we get this, and then I say any number multiplied by 0, it's gonna be 0, and then we're gonna be left with x minus 1 over 5 over 3 minus 1 over 2 times 5, ne? And then we're gonna work here, the one that I circle with red. Okay, we're gonna work with that.
Okay. So here on the f x0, we always change into y0 and y1.
No,
we only change the...
No, here I was just showing you that f of x0 is the same as y0.
Oh, okay.
So here we have y0, we also have y1. So we just substitute. Here I was just showing you that f of x0 is the same as y0.
Oh,
yeah.
Okay.
Yeah. Okay. So moving forward, remember I said we're gonna be working with x minus 1 over 5, 1 over 2 over 3 minus 1 over 5 times 5. Okay, and then here I said 3 minus 1 over 2, it gives me 5 over 2, okay, times this 5, and then we're gonna rewrite it like this. This 5 I multiply with this one because it's the numerator, so it's going to be 5 into x minus 1 over 2 over 5 over 2, okay? Yeah, we were here. And then now let's simplify this. So we're just going to take this. I gotta remember 5 over 2 like this. Is the same as we have 1 at the bottom. We can change it and then write it as 2 over 5, right? So which means, let me just write it the other side. We were here, okay, I just copied that one. It's gonna be 5 into x minus 1 over 5 over 5 over 2. So here we're just simplifying. It's just basic mathematics. It's just basic mathematics. So now from here we're gonna write it like this. It's gonna be 5 into x minus 1 over 2 over 5 multiplied by 2, like this. Do you agree? Do you agree?
Yes.
Okay.
Yes.
So therefore it's gonna be 10 into x minus 1 over 2 over 5, and then our p of x is gonna be 10 divided by 5, it's 2, so it's gonna be 2 into x minus 1 over 2. So remember, this is what? This is a linear interpolation. So you see we have a linear equation, 2x minus 2 into x minus 1 over 2. This is a linear equation. You see that? Because we're doing a linear interpolation. So this is our polynomial. This is our linear interpolation. And also they asked us to determine what? The f into minus 1 to estimate. Then use the polynomial to estimate f minus 1. Or from here we can just multiply, and then we're going to have 2x, and then 2 times half, it's 1. So therefore our p of x is going to be 2x minus 1. And remember, they want us to estimate to estimate f into -1. So we can just write this p in terms of f, because we are given that f into 1. So we can just write f into x is equals to what? 2x minus 1. And then this shows that the value of x here, it's what? It's equals to -1. Therefore, wherever there is there's x, we're going to put what? A -1. So therefore, when we estimate f into -1, it's going to be what? 2 multiplied by -1 is -2 minus 1. So therefore, the answer here is going to be a -3. Yeah. That's how example 2.1 it's done. Okay. You just use the formula and then you substitute. You'll be given your points. You'll be given your points Q and R, and then you write your equation, the formula, and then you substitute and simplify. That's it. Did you get that? Yes, that's what you do under linear interpolation. If it's quadratic, you're also gonna do the same. Quadratic, we have the formula for quadratic. This is the formula for quadratic, and then you substitute your values, okay, and then you simplify. That's it. Here you just use the formula, okay, and substitute. Here they say we have to estimate f of -1, which means wherever there's x, you're gonna put the -1. Yeah, it's 8:30. At least we started with unit 2. Do you want me to continue maybe for 5 minutes, or should we stop? Hello?
When are we going to attend the next class?
I don't know. Tomorrow I'm not available. I don't know if you guys also want to attend on Friday.
Yeah, Friday is fine for me.
Same time or different time? Friday I knock off at 3. So I get home around 4.
Let's do same time, because this coming weekend I'll be on standby. So around 5 I'll be going to work, but by 7 o'clock I'll be back.
Okay, so Friday at 7.
Yes.
So we'll continue on Friday, or should I do at least few things? Just
you can write this well.
The base for 5 minutes, 4 minutes now. We're gonna end this session at 12:30.
Okay, no problem.
Okay, so now we are continuing. Remember there we were doing the interpolation. Okay, we're doing interpolation, and now let's continue and do the finite difference interpolation scheme. Now here we're gonna be drawing a table. Okay, so here we're gonna be doing a finite difference interpolation scheme. Interpolation scheme. Okay, like this. We're gonna do this. So here we have 3 types of finite difference scheme. Okay, we have 3. Remember there we had 2 we have 2 interpolation, linear and quadratic. So this side we have 3 types of finite difference. That side we're doing interpolation, 2 interpolation, linear and quadratic. So here it's gonna be finite difference interpolation scheme. So we have 3 types of finite difference. The first one we call it forward. Okay, we call it forward difference. And then this is how we write it, changing f. Okay, we write it as changing f or dy over dx. Okay, and then number 2 we have a backward difference. difference. So this is how we write the backward. It faces down, or d square y over dx squared. So this one is for what? It's for backward. Okay, backward. Remember I said we have three. We have the forward difference, the backward. The third one is divided difference. Okay, so the divided difference, we're gonna use delta sign. That S, I don't know if you've seen it, it's there on the textbook. It's more like S, so we call it delta F. Okay, here we're gonna write it as d square y over dx dy. So this is for divided. We have the forward difference, we write it as change in F. Okay, and then we also have backward difference, it faces down. Okay, the backward, it faces down. And then the divided, we use this sign, we call it what? Delta. Okay, call it delta too. For divided, we use this sign. So from here, oh, it's past. Okay, we're gonna continue on Friday, guys, with this finite difference interpolation scheme, ne?
Okay. Can you please give me the other formula for divided difference? I can't see it properly.
Okay, so it's that as f into d square y over dx dy.
Okay.
Yeah.
Thank you.
Okay, yeah, we're gonna continue on Friday. Same time, you're gonna use the same link to join. Okay.